Hey guys, alright, we'll talk about the math review today. Alright, let's go through this to make sure everybody's on the same page. First up is Sig Figs. How many Sig Figs are in these numbers? So, number one here, start off. Again, the 8 and the 3 are obviously Sig Figs when we write it down. We got to just decide whether they're place-holding zeros or measured zeros, right? So, are these in between two numbers, that's always going to be a measured zero because that's going to be significant. This last one, this 0.0, is that a measured or is it a placeholder? Well, if I take the number away, it's the same number, 803. So that's 803.0. That's actually going to be 4 sig figs because it's not a placeholder. Whereas number 2, these zeros, these 5 zeros, are placeholders. That's 9.6 million. Right? If I take a zero away, I change it drastically. 960,000 to 9.6 million. Big difference. So this would only be 2 sig figs. Number 3, well, 1 dozen is 12. That's an exact number. Number 4. All right, so number 4, these first 2 zeros are placeholders. Right? Because if I take one of those away, they change the order of the magnitude. This last one is measured. It's measured, right? Because your calculator would just give you 0.0056. It would not put that 0 down because it doesn't change the number value, right? But this would be like 5.60 milligrams. That would work. So this is 3 sig figs. Same thing with number 5. I have 2 placeholders and 1, 2, 3, 4, 5 measured numbers. All right, number 6, 36,800.0. All of them are. So that's 1, 2, 3, 4, 5, 6 sig figs. All right, in number 7 here, there's our decimal point. So that is measured, right, like 7.980 grams. That would be 4 sig figs. 8. Number 8 here. All right, so placeholders, measured. So I have altogether 4 sig figs. Number 9. 5 oranges. Well, that's a count of a discrete number of objects, right? That should be exact. All right, if I say how many oranges do you have in your bag, you should be able to tell me 5. Not like it's 45,000, right? 45,000 would be a different story because then there's some error there. But 5 shouldn't be any error counting. And number 10. Number 10 looks like I have sig fig, sig fig, sig fig, sig fig, place. Right? Because that's 60,890 versus 6,089 if that 0 goes away. So that's a placeholder. So we only have 4 sig figs. So there's your 4 sig figs, 5 sig figs, 2 sig figs, whatever it is. Right? We just, again, the trick is finding out, is that 0 a placeholder or is that 0 measured? Number 2 here, scientific notation. All right, with scientific notation, this is hopefully not as confusing as sig figs can be for some. All right, so 8.25. Everything we write in scientific notation is significant, by the way. 8.25 times 10 to the 6th. All right, because we start right here. 1, 2, 3, 4, 5, 6. This way. 1, 2, 3, negative 3. So 6.52 times 10 to the minus third. This one, we just go minus 1. 3.06 times 10 to the minus 1. Start here. 1, 2, 3, 4. 5.65 times 10 to the 4th. 15. I go here. I got 1, 2, 3, 4, 5. 2.99 times 10 to the minus 5. Doing good. Number 16. Well, we got, start here, that's 3, that's 6, that's 9, 10, 11. 9.1 times 10 to the 11th. 17, start there. 8.56 times 10 to the 3rd. 18. 1, 2, 3, 4, 5. 5.28 times 10 to the minus 5. 19. We start here again. 3, 6, 9. So 8.69 times 10 to the 9th. And finally, number 20. 9.58 times 10 to the minus 2. And there's scientific notation for us. Hopefully that wasn't too much. Now we'll go the other way. Change the following numbers out of scientific notation. Alright, so I like to do this. I always like to put 0 point, because now you know there's, like, it wasn't just a 0.0. Did I accidentally touch the pen into the paper there, or is it really a decimal point? Especially with pencil. So 0, 2, 3, 4, 5, 6. I leave this little space so it's easier for me to tell, to count the zeros. So 1, 2, 3, 4, 5, 6. So 7 would be 8, 9, 9. Just like that, right? So I go, just got to make sure. 1, 2, 3, 4, 5, 6, 7. So that works. The next one is 960 times 10 to the negative 3rd. So 1, 2, 3, right? 0.96. Now, I keep this 0 because it's written in scientific notation. I'm assuming that's significant. 728. 7,280,000. 299 million. All right, and then 1, 2, 3, 4. 1, 2, 3, 4. Negative 4. Okay. 26. 4, 2, 9, 0, 0. All right. 1, 2, 3, 4. Always check. 0.83956. All right, 7.53. That's easy, right? Anything times to the 0 power is 1, right? So x to the 0 is 1. And x to the first is x. All right, so I have 0.00985. And finally, 109,000. That's going opposite. So numbers 31 on, this is more what we need to be, our speed here that we need to work on. Hopefully the last 20 questions were pretty straightforward. This is where, if you get a number in your calculator, and I need to go to 3 Sig Figs, how do I make it 3 Sig Figs? Right? How do I make the number I'm seeing 3 Sig Figs? This could, I mean, I'll be honest with you. 3 Sig Figs is most of the time what we're going to have. Sometimes you'll have 4, sometimes you'll have 2, right? But most of the time, once we get going with our problems, especially when we get past Chapter 2, it's going to be 3 Sig Figs for the most part. That's like the standard operating procedure in Chem 1 and 2. Now, as you get more advanced, sometimes you get more Sig Figs, sometimes you get less Sig Figs, depending on what you're measuring. But most of the time, we're going to try to do 3. So how do I report this to 3 Sig Figs? And now I can use scientific notation to really show you the 3 Sig Figs and help with making it so that it's obvious, right? We want to make things obvious to people, right? We want to make things very clearly communicated. We want to clearly communicate our numbers to people, right? Hopefully you write neater than I do even, right? Which is not that hard. And then you write, and so it's clear what this number is. 898,000. So 898,000. Well, I would use scientific notation. Put the decimal right there. 8.98 times 10 to the, what, 5th? There's obviously 3 sig figs now, and it's 10 to the 5th. 32. So this is 1.9, right? 1, 2, right? Times 10 to the minus 3rd. But 1.9 is 2 sig figs. So I need to add this 0. I need to add that 0. It's added. Right? I just threw it in there. But here's the thing. I could potentially weigh 1.90 milligrams, right? That's not unreasonable. And so there could be data there. Now here, I have 1, 2, 3, 4 sig figs. So you could write this as 3,610 or 3.61 times 10 to the 3rd. Either one clearly conveys 3 sig figs. Most of us like to do scientific notation, but not always. And not always will it be the best. Right? 714, for example, you could just leave it as 714. I could just write 714. I could do 7.14 times 10 to the 2nd. Either one works. That's your call, right? You're the author. Okay? So down here, usually when we get between 0 and 1,000, if there's no zeros, it doesn't really matter. If there are zeros at the end, if this would have been 700, I would highly encourage you to use scientific notation, because then you're clearly communicating zeros. But it doesn't matter in 714. Now, 31 and 32, it was nice to use scientific notation because the numbers are bigger or smaller than 1 to 1,000. 35, scientific notation again. Now, I would eliminate that guy, right? 6.51 times 10 to the minus 3rd. And I got 3 sig figs. In 36, all this in the calculator would be gone, right? It's just, you can either put 0.325 or 3.25 times 10 to the minus 1. Either one's accurate. Either one's good. Now 37, I would use scientific notation. 5.00. I have to add 2 numbers to get sig figs, right? Because these are placeholders. They do not have data. Times 10 to what? Minus 1, 2, 3, 4. Okay. 38. I would just simply 489 works great. Now, could you do 4.89 times 10 to the 2nd? Sure. Either one. 39. 3 sig figs. 1, 2, 3. 6.00 times 10 to the minus 2. And I would definitely use scientific notation there because that clears up. You have 3 sig figs and it's 0.06. And 40, you could do 9.61, and that's probably the easiest way to do it. You could do 9.61 times 10 to the 0. Either way, I'd probably just write 9.61 down. That's easier. Okay, but they're both correct. They're both correct. All right. Now, algebra review. The good news is you have documentation on your resume that says you are proficient in algebra. Some of us, absolutely, like, yep, got it. Some of us, that might be a little sunny side of the truth. But that doesn't matter. We can all do this. All right? So, we are solving for n, whether we get a number for n or we get an expression for n. Because some of them I don't think we saw. I think we just have letters, which is numbers, which is fine. So, n is right here. I got to get n by myself, or by itself, excuse me. And so, minus 7 from both sides, right? So, that would give me, what? 6n equals 36. Divide both sides by 6. So n would be 6. All right. And this 6. Same thing here, 42. I have n and I have n. So let's get the n's on the same side. So I'm going to subtract 2n from both sides. And then I'm going to add 4 to both sides. Right? So that means I get 9 equals n. Works out good. 43. Well, here's n. Okay. First thing up, minus 2. So then I get 3 n squared equals 75. Well, divide by 3. So then I get what n squared is 25. Square root both sides. So that gives me n is equal to plus or minus 5, right? It's a minus. Plus or minus 5, because negative 5 times negative 5 would work. E equals NHV. Or it's actually NH nu. We'll get there. All right, I have to solve for n. So that means I'm going to divide both sides by h nu. So that means E over h nu is n. And that works. 45. Where's n at? N's here. N's here. Well, I'm going to do the opposite that we normally do. Right? Normally, we factor. I'm going to do the opposite. P equals n times RT over V minus B. All right? I'm going to do that. Tricky, tricky. Then I'm going to divide by all this. All this is going to come over. So I'm going to get P over RT over V minus B equals n. And that's it. That's all it is. Number 46. All right, so I got to subtract 2n squared from both sides. And then I have to add or subtract 4 from both sides. So if we do this, I get 3n squared equals 6. Divide both sides by 3. Looks like I get n squared is 2. So that means square root both sides, n equals plus or minus the square root of 2. Wonderful. 47. Now this trips some of my students up in the past because we have a negative exponent all of a sudden. So what's the first step? Add 9. So 4 n, I put n down. 4n to the negative 2 equals 1. All right. So how do you solve this? Well, I got to get things, all right? So if I multiply, well, if I divide both sides by 4, I can get n to the negative 2 by itself. 1/4. Now, negative exponents, little sidebar. X to the negative 1 equals 1 over x, right? If that makes any sense. So I'm going to do 1 over n squared equals 1 over 4. Okay. Now I'm going to cross multiply here. If I cross multiply, I get 4 equals n squared. And then if I take the square root, I get plus or minus 2 equals n. And there we go. So negative exponents, all you have to do is take them above or below. You can just, if they're negative on the bottom, you can bring them up, they're positive. If they're negative on the top, you bring them down below, they're positive. And then you can go from there. It makes it easier to work with. Number 48. Solving for, of course, n. Well, n's on the bottom, so let's cross multiply. Cross multiply. If I cross multiply, I get 3 pi r squared x equals 9 r squared n. Well, divide both sides by 9 r squared. And we get 3 pi r squared x over 9 r squared equals n. And now, that's fine. It does not say simplify. Could you simplify? You could. So you know, 3 over 9 is the same as 1 over 3. Pi, r squareds are gone. So, all right. So basically, make this neater. I get pi x over 3. All right. Because the r squareds are gone. The 3 and the 9, right? Becomes 1/3. All right, 49. 49. We have elimination here. Okay, I gotta get something to cancel. I can get the x's to cancel. Right? I don't want x. I want to solve for n. So if I take the top expression and multiply that by 3, and the bottom expression and multiply that by 2, right? Let's see what happens. So we get 9n minus 6x equals 45. And then I get 10n plus 6x equals 88. Well, if we add those up, what happens to the n's? Or the x's, excuse me, they're gone. And I get 19n equals 5 and 8, 13, carry the 1, 12, 13, 133. So 19n equals 133. Divide both sides by 19. All right, so there you go. You get n equal to 7. And there's 49. All right, that's elimination. That's going to be helpful because we were actually going to do something similar to this in Hess's law. And last but not least, 50. Got an exponent on the bottom. So the first, I'm going to do two things. I'm going to move this down, and then negative 1/2 down, and I'm going to move the 7 over. So I'm going to subtract 7 from both sides. So we're going to get 27 n to the 1/2. Now n, oh that's funny, n to the 1/2 is the same thing as the square root of n, right? Just so we're on the same page. I'll keep it as 1/2, but there we go. And that equals 16 minus 7. So 16 minus 7 would be 9, right? Okay. Now, I need to multiply both sides Is that going to work? Yeah, multiply both sides by n to the 1/2. So 27 equals 9 times n to the 1/2. And then divide both sides by 9. So 27 divided by 9 would be what? 3. 3 equals n to the 1/2. Well, square both sides. Oh, undo. So 3 squared is 9 equals n. There we go. And that's 50. All right. It's just practice. We don't have now. If this is stressing you out with the negative exponents and the half and whatnot, we don't do a lot of that in Chem 1. We do a lot more things like 45, a lot more things like 49, 44, 48. Okay, that's a lot more what's going on. All right, now this is estimation. We're going to estimate here. All right, we're just going to estimate. The last 10 are just estimation, and I'll show you how I'm going to do it, just so that we get a ballpark of what the answer should be. Because do not just blindly trust your calculator. Okay, blindly trusting the calculator is not a good idea. We should know about what our answer should be. Just like if we go to the store, we should know what we're spending, right? Whether it's the grocery store. I've gone to the grocery store before, and you know, I've ordered. I know I got a piece of meat, and it was like a standing rib roast or something. My wife likes to cook a lot, and she likes to do extravagant meals for holidays, and it's wonderful. So we were buying I think it was a rib roast or something. And the piece of meat was going to be $100. It's a big piece of meat. And the lady rang it up, and it was like $17. And there was no way it was $17, right? So we fixed it, and it worked out. Another thing happens when you go to like a department store. You know, you go buy clothes. Like me, if I go buy a dress shirt, buy one, get two free, right? That happens all the time. But if you go up there, they're notorious for not giving you that deal right away. Oh yeah, so it's a $50 shirt or $60 shirt, but if you buy one, you get two free. Great. So you go up, you're expecting, between $60 and $70, right? That's just a good, because it's less than, 10%, so it's probably going to be close to $65. But, between 60 and 70, I'm not going to be alarmed. Okay. Well, you go up there and they say, well, instead of 60, right, they say like 198. You're like, whoa, I thought these were on sale, right? Hopefully we do that. Well, the same thing happens for your class. Like, take a second, and does this answer seem right? Because I've asked for like a handful of copper before, like 20 grams of copper. How many, or like how much does that weigh? I give you the atoms that you could hold in your hand. How much does that weigh? And people have given me the mass of the sun, the mass of the Earth, the estimated mass of the Milky Way galaxy. Like, just huge. Like, oh, it's 1.75 times 10 to the 54th grams. Like, really? 54th grams? That's a huge number. Like, that much? No way, right? And so make sure we look at our calculator and think, does this number make sense? So here's how we estimate, right? Added up the powers. 230 is 10 to the 5th, correct? That's it. It's negative 6, 9, 10 to the 3rd. Okay, and this is close because it doesn't really matter what numbers are in front. So if I'm going to get something close to this. 53. So we have, what do we have here? Now I would break this up. All right, the first one, that's negative 10 to the minus 11th. If I did it, right? Because that 8 comes up, it becomes negative. Negative 5 and negative 3 is 8, so this is 10 to the 10th. So that's 10 to the negative 1 squared. 10 negative 2. And feel free to do this in your calculator after the fact and say, oh, we're pretty close. It's amazing how close we get estimating sometimes. 54, 10 to the 4th, 10 to the negative 10th. That's a 10 to the negative 6. All right. And that comes up, 10 to the positive 6, and 10 to the positive 6 would be 10 to the 12th. All right. Now, 55. This is a good one. 800. This is really close to 200, isn't it? So 800 divided by 200, which is 8 divided by 2. 8 divided by 2 is what? 4, right? So overall, this is overall 4 times 6. Just ignore that. 4 times 6. 6 times 4 is 24 times 10 to the 23rd, or 2.4 times 10 to the 24th. That's it. All right, and that's going to be pretty close to what our actual answer is. Right, and we only have one sig fig, so technically that's just 2 times 10 to the 24th, which we're probably right. 56. All right. So look at this first one. This is 30 over 58, which is really close to 30 over 60. And 30 over 60 is 3 over 6, or 1/2. All right? 25, that's really close to 4. What's 25 times 4? 100. Right? So 1, 2, 3, 5 zeros. Right? I have 100 times 5 zeros. Well, I'm sorry. I have 5 zeros, but then I'm going to divide it by 2. All right? So 1/2 is 0.5. So 5, I have 1, 2, 3, 4 zeros, I would think. 50,000. Now, 57, 58, and 59 are a little bit, you can kind of go. I would say this is definitely 6. You could call that one 6 or 7. Let's call it 7. And you call that one, I would just call it 10. All right. So 6 times 7 is 42. Times 10, 420. Then I got 10 to the 23rd, negative 34, and 15. All right. And so, just how I do it. Right? 23 and 15 would be 38 minus 34 would be 4. So 4.2 times 10 to the 6. All right. And that's how I would do that. 58. All right, so this 0.08, I would just call that 0.1. 10. So 0.1 times 10 is just 1. And that's 300 over 20, which is 30 over 2. So I'd say that's 15. And so again, it's about 15. So if my answer is anywhere from 10 to 20, I'm happy. I'm like, yep, that looks like it's about 15. All right, perfect. And so I think the answer is around 12. Could be wrong. I don't remember. But that's close. That's great. All right. That would be great. 59 and 60. All right. There's, again, there's a couple ways you can do this. All right. You can make the top one 6 or 7. It doesn't matter to me. All right. So if you make this 7, make that 9, and make that 3. That's fine. So what's 9 times 3? 27. So I'd have 7 over 27. And again, this one's a little longer. You probably, I don't know, I would probably just look at the order of magnitude and make sure. But 7 over 27, which is the same thing as 7 over 28, right? That's really close to 7 over 28, which is really close to 1/4, or 0.25. Times 10. So we got negative 31, 34, I got 6. So if I bring this 6 up, that's negative 40, right? Is that negative 9? Right? Or 2.5 times 10 to the minus 10? Somewhere in that range is what I'm looking for. Now again, this is a little much, but if you do this a lot, yes. If you don't do this a lot, no. It's a skill. Next one, right? How would you look at this? Well, you can make the top one 6, 7. I'm going to round, obviously that's a 5, right? I don't know what I'm going to do there. If I'm going to make this a 9, make it a 6 or a 7, it doesn't really matter. Okay, it doesn't really matter. I'm going to make it a 6. And this time, you'll see it doesn't really matter. All right, so what do I have here? I have 6 over 4, make that 3, because I'm rounding this down, I'm going to round that down, times 3, times 9, times 5. All right. So I would make this, what? That's 6. So make that a 2. All right. And so 4, make that a 2. Does that work? 10, 90. Yeah, 1 over 90, which is, right, 1/90th. Right. Again, you're just 1/90th is a small number, times 10. Now this is 10 to the minus 2. So I have 31, 33. All right. And I have the 6. All right. Maybe you want to do it this way, where you have 10 to the negative 34, you add that up, I think that's negative 27 overall. Again, bring it up, I get 10 to the negative 7th. It's up to you how you would do that, right? Again, and so this is turns out to be about 1 times 10 to the negative 9. Small number. The bigger thing with this is noticing negative 34, negative 2, 6, 31, and doing the yellow. The yellow is way more important. All right? Okay? The yellow is way more important. And if you'd have got negative, anywhere between negative like 8 and negative 10, or right, in your estimation, you'd be good. All right? That's what I'm more worried about, right? Because in scientific notation, when you have numbers, it doesn't matter what the numbers are. A dot BC, right, times 10 to the power P, we'll call it P. P is way more important than those numbers up front. Okay? P is much, much more important. So this is much more important. All right? Okay, that makes sense. That's way more important. Well, a lot of people say, well, I got A, B, and C right. You know, if it was 6.54 or 3.21, whatever those numbers happen to be. Right? I got A, B, and C right. Yeah, but you're off by 20 orders of magnitude. That's big. Really big. So P is more important than A, B, and C. All right? Way more important than A, B, and C. All right? Okay. For example, if let's say it was 1.254 times 10 to the third versus 1.254 times 10 to the second. Right? Well, this is your weekly paycheck. That's a big difference, don't you think? Right? Because this is $1,254 a week, which a lot of people, that's really nice. That's better than the median household income. This one would be $125.40 a week, which, again, I wouldn't turn down, but I don't want that to be my income, right? That's not a very good income at all, right? And so, right, that's a big difference. And then it's the exponent. That's way more important, all right? So hopefully that makes sense. This is not designed, especially these 58, 9, and 60, not designed to scare you. It's really designed so that you look at these powers and making sure these 10 to the whatever powers are giving you the rightish order of magnitude. That's what's important, all right, so that we get in the ballpark. Okay. Let me know if you have any questions.